All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanaugh here. Year 18. We turned 17 years old last month. Pretty exciting stuff. And the more things change, the more they stay the same. But I will say, one of the topics we talked about way back when in 2008 was ending the madness of ETL. I'd wrap my head around what ETL is, how it works. I'd been working for a business intelligence consulting firm and then for TDWI, the Data Warehousing Institute. So I knew what ETL was and I understand its importance about pulling data from operational systems, transforming it to fit into a schema that fits in a data warehouse somewhere, for example, so you could do some analysis on that data. Well, what had happened is that companies figured out it was really hard to query an operational system like an ERP. They weren't designed for querying data. They were designed for transactions, for getting things done, for keeping track of things. So that's where the whole movement came from. But then about 10, 12 years ago, I guess it was, something spun out of LinkedIn called Kafka. It was an open source project, and it was the engine that drove Kafka, basically a messaging service, a streaming data service where you use topics and you stream the topics. And from the first time I heard of this, I was like, well, that sounds pretty cool. It sounds like a new way of doing things. And since then, streaming has really taken off. There are multiple different technologies you can use, multiple different methods you can use. Of course, Kafka is still out there. Confluent sits on top of that. I've got some fun case studies from my experience talking to those folks. But then there are other engines too. There's Flink, which seems to be making a bit of a comeback. Pulsar is another one. And then, of course, there's Redpanda. And we're going to talk about that from one of the key players over at Redpanda today. But first, I'll bring in William McKnight here of McKnight Consulting. And William, you've been focusing on this stuff for about as long as I have. Maybe just give us your opening thoughts here on streaming as a construct, as a way of getting data, as opposed to traditional ETL or ELT as it's sometimes done. What are your thoughts on streaming overall, and where does the market stand right now?
The market is increasingly moving towards streaming as opposed to ETL because it is the best method for handling the large amounts of data that we now have to handle and get under management. It's actually the only elegant solution for that kind of data. So you can try to force that kind of data, that's fast-paced, high-velocity data that we all have, that we've been ignoring for years, but now we see that we can get value out of that. So you can try to force that into the old ways of doing things, the ETL, as you mentioned, but really only stream processing can handle that. And this data actually becomes the foundational data, this detailed data that stream processing handles becomes the foundation for artificial intelligence in an enterprise, whether that data be moving into a lake or a lake house or a warehouse, what have you. That's the core data for AI inference and AI execution within an organization. So therefore, it's very important. And that's where competitive advantage is being shifted towards. We're all kind of expected to have our ETL under control for that non-high velocity data. But the high velocity data, that's where we can actually set ourselves apart. And stream processing handles that.
Hmm. And I'll bring in Brian Schwartz from Red Panda. And of course, you folks went out and rewrote a streaming technology so it could be a Kafka drop-in, if I understand it correctly, but much more efficient. But first, tell us a bit about yourself and your journey in streaming data and how you got to Red Panda.
Yeah, thanks for having me. Brian Schwartz, I'm the VP of products here at Red Panda. Been at the company about a year. So I'm actually relatively new to the streaming space. I'm old enough, had a little bit more hair earlier on. I've been in the tech industry 25 years. I'm on my fourth startup, done a couple big companies, worked at Google Cloud and a couple other places, did a spin into Cisco at one point. So I would say a tech veteran but relatively new to the data space. And it's been really fun and interesting to me to really dive into the space in the last year. I certainly got attracted to joining Red Panda, because the people, love the colleagues I have here. Alex in particular is the CEO and co-founder. But also, just the opportunity for streaming. I saw a lot of the things that you guys have mentioned that streaming is the foundation for a lot of the business processes that are out there today. Obviously, I've been around. I've done a lot of work on ETL and databases over my career and things like that. The real-time nature of data, the needs for most data to be real-time accessible is just so much more prevalent now than it was 5 or 10 years ago.
Hmm.
I attribute that to just the general growth of the internet, the general growth of mobile apps. I kind of, try to explain to people when I'm trying to explain to, non-tech folks about what is streaming and why do you care. Use like the credit card analogy. When you swipe your credit card, there's a lot of things that need to happen fast on that transaction. Okay. There's fraud detection. It obviously gives you approval to do it. But also it decrements your credit balance. It needs to show up in your app for your reporting. My daughter's got her mobile app up, and every time she can go and see her transactions show up right away. There's just a need for so much data to service, business processes today, whether they be kind of consumer things like, credit cards or more, B2B things in supply chains and manufacturing and things like that, where all this data, the real-time accessibility of the data is so much more important. And I think we'll talk about AI a little bit later. That's certainly only accentuating the need for it, but it's been super interesting to me to see kind of the growth and kind of excitement about the space and how most modern I think companies are gonna, data is the asset of the company, need a real-time streaming infrastructure. And
Hmm.
I believe Kafka is the right approach. There are other approaches out there. Message queues have been around for a while. You guys have probably seen some of these.
Sure.
There's been a lot of different variants of these types of architectures. But Kafka is the one over the past, to your point, Eric, past 10 years, it's really grown into an industry. Credit to the folks that spun out on LinkedIn who created it with the Apache Kafka project itself. But it's a wide-ranging industry with a lot of participants and obviously a massive number of people who actually use Kafka-based systems today, and frankly, more and more every day.
Yeah, no, it's very interesting stuff, and it is a different way of delivering data. So if you think about the architecture of applications and databases, historically, you have a database that stores your data. You have apps that sit on top of it. They talk to that database to get the data they need to transact for whatever purpose it is. This is a little bit different now that the data is streaming constantly, and so I use the analogy of water flowing through pipes, and then sometimes you turn the pipe on, sometimes you're the faucet on, sometimes you turn it off. When you need it, you turn it on. When you don't want it, turn it off, basically. And in this new architecture, any number of people can subscribe to a topic as it's described, which in and of itself is a pretty interesting development because you used to have ETL processes that were separate to each one of these environments. Now, if you just subscribe to the topic, you get whatever is coming from the topic. So, from an architectural perspective, it saves time, it saves effort, at least theoretically. In practice, I realize you never know what's going to happen sometimes. But from an architectural perspective, it's a very, very different thing, but how much work do you need? I'll throw it over to Brian first on the receiving side to be able to process that information. Is it a sort of net new environment you have to create, or is there a sort of impedance mismatch between how streaming operates and how many applications work today? Tell us about that a bit.
Yeah, so it's really interesting. An easy way to think about streaming and Kafka is there are topics and there's publishers and subscribers, basically, people who push
Mm.
data into topics, other people who subscribes, and they can be many to many relationships. You can have many people publish to a topic and many people subscribe, or many, not people, but applications is really what they are. And to your
Right.
point about integration, I think the integration has gotten quite a bit better over the years. Certainly here at Redpanda, we have a portfolio of nearly 300 connectors at this point that plug into all manner of enterprise applications like standard package apps, your SAPs of the world, a wide number of cloud services that come from all the hyperscalers, various AWS, GCP, and Azure services. We support a ton of connectors for Apache, open source projects as well. So
Hmm.
there's really a lot of off-the-shelf connectors at this point to get your app integrated into Kafka, regardless of whether it's going to be a publisher or a subscriber. And I think that has lowered I would say, the taxes or complexity of getting apps connected to each other, which
Hmm.
historically has always been I would say, a big effort for most IT teams to make sure their application landscape is kind of well integrated. And this kind of concept of off-the-shelf connectors and making it much easier to do, I think simplifies that. And to your point about impedance mismatch, I think this is it's an important word you said there, which again, you think about apps, they operate at different speeds and they have different peaks and valleys and things like that. They go through different upgrade cycles, and some apps are really smooth online upgrades, distributed apps, kind of node by node, and other ones are not, more historical apps that, people still have to shut something down at 2 a.m. on a Saturday night kind of thing.
Right.
Uh, One of the huge benefits of Kafka and systems like Redpanda is they they basically give you that ability to deal with the impedance mismatch. It's stateful, Kafka systems like Redpanda, they're stateful storage, so we can cache data. If you're going to need to go and update your subscriber and you turn it off, we store the data, inside the Kafka system, and when your app comes back up after the upgrade, it knows what offset it stopped at and can just continue going forward. So you don't need to deal with I tell people it helps build loosely coupled application integrations. And that's really
Mm,
important because if you just build one-to-one app integrations, they're kind of tightly coupled. And if you turn off one app, then the other app has nowhere to push the data. Like what happens to it? In some cases, it may get lost. And like
right.
with a credit card transaction, that's not acceptable, like for a lot of business processes. So this concept of being like a loosely coupled system between different applications, I think is a really important capability of applications like Kafka because many people have hundreds and thousands of apps and they're all manner of upgrades and peaks and valleys in performance, and having like this foundation that allows you to have these loosely coupled designs for app integration is like a really powerful foundation that allows you to upgrade your IT estate kind of more operationally efficiently. uh,
Yeah. That's a really, really good point. And William, I'll throw it over to you. This concept of loose coupling comes back from the service-oriented architecture days, right? And loose coupling is where, to Brian's point, it's not a direct one-to-one connection like you would typically see in like an ETL process. So that's, you could argue, tightly coupled. But the problem with tight coupling, even though it can work faster to get one particular job done, is that it's pretty brittle. And so if this one goes away, the process is truncated, it's not as easily manageable. And what do we want in the world of especially cloud enabled enterprise? We want durability. We want endurance. We want things to continue to work even when stuff breaks. But what are your thoughts, William, about loose coupling as almost like table stakes for modern enterprise systems?
Yeah, I'm glad Brian brought that up. He's absolutely correct. That's a huge value proposition for streaming data, because it used to be when we didn't have as much data and data wasn't deemed to be that important and AI wasn't on the table, we could predict what our architecture was going to be. We could lay it out. We could move that data through the architecture in a predetermined way. But now we've learned that that's not quick enough for organizations to respond to the market. And they need to be able to spin up applications quickly, subscribe to topics that are already prepared, already flowing through the organization. I just need to grab that topic and I will have the data that's already governed, that has gone through that sort of data quality check and company blessed, and I can actually use that data. So that has enabled a whole host of new applications within the enterprise, because they don't have to go through that onerous step of, okay, I've got to get the data, and the data I will get probably will be wrong or probably will not be governed, and I'll probably have to architect a new tight connection. That was really the bulk of the work effort that we had in those applications. And now we can work more on the application itself because the data is flowing and we can grab it.
Hmm.
It really helps with the speed of application design and deployment. Like
Yeah.
fundamentally, these issues of like data quality and things like that, to already have all these topics that have all the different kind of information streams in your company available, it really helps. Obviously, people build a lot of these microservices apps now. They really want to have app velocity and reduce the taxes on app teams to deal with data quality. And obviously, there's security and compliance issues. Like all these things are kind of worked out in a topic-based, real-time streaming environment. So it just makes it easier for people to innovate and add new things, and there's less coupling inside the organization. The apps are loosely coupled, but some of the teams can be a little bit more loosely coupled than they have been in the past too. Which the larger your organization gets, the more beneficial that is. Like if you really think about it.
Yeah, that's a really interesting concept too, and it gets me to one of my favorite topics of discussion, which is opportunity cost. Right? There's opportunity cost to not be doing things, basically. And when I think about developer experience, for example, if you have this streaming architecture, if you have this topic orientation, you're greasing the tracks for developers to try new things, to do new things, to get their apps deployed. And there's a real opportunity cost to not go down that road, because if you know it's going to be difficult to connect to a certain data system in an old-fashioned way, you're just going to be less inclined to start thinking about that stuff, right? What do you think, Brian?
Opportunity cost is the one thing that people have the hardest time judging, but it's absolutely real, particularly in a, almost every company is a tech-enabled company at this point,
Mm-hmm.
and their speed at which they can harness and get value from the data in their applications and improve their business process as a result of it. That's where business advantage comes from and differentiation for the most part. So the speed of these things and how quickly you can evolve your IT landscape is a huge competitive advantage. And it's one of the reasons why some companies, in some senses, have good innovation streams and they come out with new products and new capabilities and new things to service their customers to make the customer experience better. All these things, if you can do it faster, easier, that is a huge form of differentiation for people. And I don't need to talk to folks on this kind of discussion about why IT matters, but man, companies that do it well have flexibility and agility, and they can, you know, they don't have as many to use their opportunity cost, unmet opportunities. They have to
Mm-hmm.
bypass fewer of them, whereas it is unfortunate to see some companies through their own inertia and things like that, they have huge opportunity cost losses, basically.
Mm-hmm.
They don't do things that they could potentially do because it's too costly or complex or it'll take too long. And
Right.
it's unfortunate, but again, it's capitalism is tough. You gotta innovate or die at some level. And people who build good infrastructures and good IT landscapes absolutely have a competitive advantage.
Yeah. Well, that's true, especially in this cloud-enabled world, especially in an AI-enabled, cloud-enabled world. I mean, granted, a lot of the attention now is on Gen AI, although agentic AI is coming into much more clearer focus. And I'm hearing more and more, and we'll talk about this on the next segment, that streaming data can provide a very rich tapestry of information to fuel AI agents. How are these agents going to work? What are they going to do? For me, the big key is governance. How do you govern what the agents do? How do you stop them from doing things? Basically, is the big question, because they could just take off and do all kind of stuff, and you never know what's going to happen. So the orchestration of these things. I mean, Jensen Huang had this quote where he says, in the future, what did he say, that we'll have 50,000 employees and 100 million AI agents or something? I did the math. I'm like, really? Why do you really need that many? I'm not entirely sure, but he's obviously a much smarter guy than I am in that in that capacity. So he may be onto something, but I promise the governance side of the equation is going to be really, really important. And we'll pick that up in the next segment, folks. Don't touch that dial. I'll be right back. You are listening to DM Radio. All right, folks, back here on DM Radio, your host, Eric Kavanaugh, with William McKnight of McKnight Consulting and Brian Schwartz of Redpanda Data. We're talking all about streaming data. Of course, Kafka is what really kind of started all this stuff. Although, Brian, you mentioned MQ series. We've had messaging systems for 40, probably 50 years now. It's not new. It was the same concept, just a much richer approach, I suppose, is what Kafka brought to bear. And then, of course, Redpanda optimized that in a programming language, C++. You don't have garbage collection as much. You don't have some of these problems that they run into in the Java world. And I am told that is one of the real hindrances of Kafka when it scales in an enterprise, is you get all sorts of issues dealing with the Java engines and not being able to handle the capacity, basically. So these are things you learn in production. Everyone knows that you can design a system and it looks great on paper, it looks great, the schematic, and then you boom, hit the go button and things happen, right? Reality strikes. And one of those realities that is striking right now is AI. Everyone's talking about agentic AI. I think probably 80% of it is bluster and 20% of it is hard actual truth on AI agents. Salesforce, of course, has Agent Force, but there are lots of other smaller companies. Ascendian is someone we've been talking to. We had on our show recently. They've got an AI studio in Austin, Texas, where they're focused on an agent first architecture, meaning their developers don't write code. Their developers first use agentic AI to write the code for them. Now, what I've learned in playing around with this stuff is the large language models in particular are unwieldy. They will break. They do things differently time after time because they are very, very, very complex. So you have to be careful. And there's certain things that seem simple and just aren't. They don't iterate very well either. If you've noticed, like if you work with the image generation, for example, you'll see that it's hard to fine tune things. It'll just keep generating similar stuff the first time and then the seventh time and the 20th time. You're using up your tokens, you're not getting any closer to the goal. So there are certain things that they don't do very well, but there are certain things they do amazingly well. And that is different from AI agents. Now, you can have an agent that uses an LLM in a workflow. So that is a very common practice as well. But an AI agent doesn't need to be using a large language model. It just needs to be at least semi-autonomous and have a sort of deeper reasoning or decision-making capability. So it's not just an if-then, basically. It's an array, if you will, of if-thens that can be computed on a moment's notice. So how do you feed data to these things? Are you going to have it doing queries to your Oracle database or your Access database? And that's going to be kind of slow. So I think this is where streaming data comes in and will be more effective at getting the right kind of data to the agents as they need it to make decisions. But with that long-winded intro, I'll throw it over to William McKnight. What do you think about agentic AI and data streaming as a match made in heaven?
Yeah, I think it's a good match. I think AI agents are here to stay, and we'll be talking about it as much as anything, probably by the end of the year. They're coming on that fast. I wondered for the past couple of years, how is AI going to get into the enterprise? I mean, it's great and all. Well, I can see the
Right.
potential. We all could, but I think it'll be encapsulated inside of agentic AI, and that's how it's getting into the enterprise. And we're going to be able to, with agents, encapsulate business functions that truly will use AI to execute those functions. Kind of like what you said before, Eric, about they're kind of like additional people that think within an organization. And
Right.
so, in order to empower those types of agents to work and do their job, they are able to, and we want to empower them with real-time data. And I don't think we've mentioned the word real-time. Hopefully, it's obvious that streaming data is real-time, real-time data.
Right.
So we want to feed these AI agents with real-time data to allow it to do real-time perception and decision-making. It's streaming platforms that provide that continuous flow of data so it can do continuous learning and automation, continuous fine-tuning of the enterprise, and
Interesting.
real-time feature engineering and things like that. So I think it's a great match and definitely foundational for the future of our data architectures.
Yeah, that's a really good point. I'll throw it over to Brian to comment on the currency of the data really matters for many, many, many use cases. You mentioned credit card fraud, for example, shopping, all kind of different things. The now matters more than the past. Not that the past doesn't matter, because it'll provide context, but the now is what you really need to take decisions and do things in the enterprise, right?
Yeah, that's you guys are absolutely correct. I do think that this, interest around agentic AI is going to be one of the main drivers that drives AI into enterprises. Most people have started to really see, okay, self-driving vehicles and some of these other use cases about AI, but have struggled to figure out how it's going to play out in enterprises, where there's obviously a
Hmm.
ton of data and things like that. Um, I guess I've been lucky enough to be around a lot of good customer conversations and conversations with smart folks in the industry that the concept of LLMs in front of enterprises apps as a foundation for agentic AI, you can see how it's playing out today. You mentioned Salesforce is okay. They're pretty public about how they're doing it. Many people have used Salesforce, so I'll use it as an example. Think about an AI agent for Salesforce where you could speak to it in natural language and get it to do queries and reports for you. Most people who've used Salesforce probably don't love the reporting engine. Many companies have a team of people who build and surface reports to other folks in the organization. An AI agent, like the beauty is it's read all the Salesforce documentation, it knows the schema, it knows the structure, it knows
Right.
the API calls, but it needs the current data. It needs the data
Right.
that's actually in your current Salesforce. And by the way, that's changing every moment in a large organization. There's new updates that are happening to that thing.
Right.
So the concept of real-time data married to LLMs as like a smart enterprise app, a Salesforce agent. But think about that in context of all the other agents you have. You're going to have ones for your website. The customers are on your website, and there's data that comes from a manufacturing line that's, maybe captured in an SAP
Mm.
type system or some other,
Wow.
ERP type system or other databases people have that I can absolutely believe how there's this sea of agents that exist because there's little agents that are built out to be specialized in that app or that domain. And by the way, the agents are going to start to talk to each other. I have an example where, from a security perspective, you're going to have AI security agents that are helping find like nefarious transactions or concerning connections or things like that, helping detect fraud and things like this. It'd be nice that security agent is going to, it detects a new connection it should want to go
Hmm.
and check, is that new connection a new employee who just started 10 minutes ago? And okay, this is
Right.
their first connection and that's why it's new. And it can query, most people have an HR management database of some sort or an HR web service they use. The security agent will be able to query the HR agent and basically say, hey, is this a new employee or have you never heard of this person?
Hmm.
As you can imagine, chaining of agents across different scenarios and use cases where the agents need to talk to each other. And it really gets back to the data needs to be current and fresh. It needs to be real time, which is why certainly we believe here at Red Panda, streaming absolutely plays a role. Um,
Hmm.
and it's also about app-to-app connectivity. When you're starting to chain all these agents together,
Wow.
you have this n squared, like app connectivity problem, which is kind of why Kafka got built in the first place. So you don't have to build one-to-one connections, which once you get past a few applications gets to be really hard to maintain.
Mm.
Most people have hundreds or thousands of applications. So, kind of like this concept of a real-time message system, like a Kafka type system like Redpanda, is incredibly important. And performance matters. These things need to operate fast. If somebody's waiting on the other end for the response to come back, like latency matters, which is why
Yeah.
we've tried to optimize those things here at Red Panda. But it's a super exciting time. It's obviously still early days for AI agents, man, but you can really see how it really starts to affect enterprise adoption of AI as all these agents start to come into the organization.
Well, you're getting my brain simmering here a bit, Brian, as I'm thinking to myself, agents talking to agents. If you think about the de facto information architecture for any large company, it is outrageously complex to the point that it just simply cannot be understood by a human being. But AI with enough effort and compute power can. And what I'm excited thinking about as you're talking here is optimizing the entire environment and how things work in this environment. So noticing, for example, that there's a whole lot of compute being spent on things that aren't generating any value, whether it be cleanup of things or sort of planned processes that maybe like reports that aren't being used is a perfect example. You have the stories of all sorts of dashboards and things that have been built over the years that are not even being used. And then a company wants to switch over their BI tool and like, okay, well, the consulting firm says they're going to charge us 100 grand to move all these dashboards over to this new environment. Well, is anyone even using those things? And agents can sort of, on their own go crawl around and find stuff that's not being used and say, hey, this is not being used. That's not being used. What do you think about that for a use case, Brian?
Look, it's another really good, interesting use case, like cost optimization in a large scale company for IT. It's a
Mm.
hard problem, and it's an
Right.
expensive problem to go solve. But most organizations I've talked to, they have too many copies of data, and not all of them are well used, right? And it's actually even hard to keep track of all of them and figure out which ones you want to go, change or absolve. I'd be shocked if in this DM radio you guys haven't talked about Apache Iceberg and like open standards and formats. Like, imagine a world where you had an AI agent that could go and look at copies of database data you have in proprietary formats that aren't used that much, potentially get them into Iceberg formats. Because again, these are technical API calls that can be made in some products. Certainly here at Red Panda, we've made a big investment in Apache Iceberg support. And even go so far as to have like a second agent that could, call your analytics, tool and say, look, the data is no longer in that copy. It's in this new shared Iceberg format. Like these things are hypothetical at some point, like not a lot of folks
Right.
kind of stuff in production, but you can
Right.
really see how this kind of story plays out over time. Because if there's one thing that AI is really good at, it is software development and kind of API integration. Like
Hmm.
software development, automated software code generation is one of the hottest areas of AI development outside of like self-driving vehicles, maybe, or some things like that. Because AI agents LLMs are really good at reading tech documentation,
Hmm.
and knowing all the API calls and how to query things and how to configure them and set them up. So whether it's for cost optimization, to riff on my security idea, misconfigurations are one of the biggest challenges in security, right? Okay,
Right.
one small hole that somebody left open by accident. Think about a security AI configuration agent that's running in your organization looking for misconfigured apps and things like that. That could be potential security vulnerabilities. Like the number of possibilities is tremendous, and it's really interesting to see all the ideas, like the one you mentioned earlier, Eric, about people riffing on specific use cases or vertical industries to go. But the concept of AI agents, I think at this point, I am signed, sealed, and delivered that it is not just a buzzword, it's absolutely happening. And over the next, coming quarters and years, there are going to be dozens, hundreds, and thousands of these things in many organizations. It's
It's
more of
really
a
fascinating. Right. It's really fascinating. And we're going to be the stewards of those agents, is the idea. I mean, that was another Jensen Huang quote. He said, in the future, IT is going to be like HR for AI agents, monitoring them, watching what they do, kind of parsing their results. And you kind of hinted at something too, Brian. I'll throw over to William. We got about 3 minutes left in this segment. Is orchestration of agents. So a lot of the people I've talked to had said, what you want your little robot to do is one thing very well, and then you can have an orchestration agent that calls on the various other agents to do things. Hey, agent data guy, go get our data. Agent B, analyze that data. Agent C, go deliver it somewhere. That's a very simplistic version, but this is what I've heard, and it makes sense. Mistral, I think, has taken that approach with their LLM, sort of this orchestration of agents. But what do you think about agent orchestration and having roles and responsibilities for agents?
I mean, all we're hearing here is really the next step on the way to AI having more responsibility within the organization, almost to the point of being able to run complete departments with agents and even run complete companies, or at least be side by side with a physical human CEO running the whole company. Because once you have all these agents spun up, they're doing all the work. They're actually thinking well beyond, just executing things. Streaming architecture, obviously, a big part of enabling all that sort of automation. So yes, we're going to have to be the stewards now of AI agents, and we're moving in a direction of AI agents doing more and more within the organization. Where it all goes, I don't think anybody knows right now. When we put the brakes on this, but this is definitely a thrust of many organizations out there right now.
Hmm. Yeah, it is. And you see lots and lots of companies talking about it. Like I say, I think sometimes it is very, very true and gritty and real, and sometimes it's, a little bit of a polish on some existing automation. And I guess that this is something we should dig into in the next segment. I'll just kind of tease it here, folks. What's the difference between traditional automation of a process and an AI agent? At what point can you say, okay, this is now an AI agent? Is it because of the diverse ways it can act based upon current information? Is there, and there's also this talk about reasoning engines, and like what exactly is a reasoning engine? I mean, there's pattern recognition, and what I often think about is in a particular application, there are only so many things that can be done at any given time. And so that complexity is actually much less than the complexity of human beings having a conversation, because we can switch tracks and on a moment's notice, many people often do. And the better you know someone, the more you just sort of intuitively know when they've switched tracks and are now talking about something else. Not to pick on my wife, but she loves to jump tracks very quickly. And I'm like, wait a minute, what are we talking about? Oh, that, okay, yeah, that's what you're talking about now. So can the agents figure that stuff out? It's very, very interesting stuff, but we'll pick that up after the break, folks. Don't touch that dial. You're listening to DM Radio. All right, folks, back here on DM Radio. Fascinating conversation with Brian Schwartz of Redpanda Data and William McKnight of William McKnight Consulting. And I'm going to throw the hard fastball over to you, Brian. Like, what's the difference between traditional automation of a process, even dynamic automation? Because we've had code generation for, I mean, I watched a friend of mine do dynamic code generation on call 30 odd years ago. So that's not new. In other words, some request comes in and you spin up code to do something and then it does something else. That's not new. But how we're doing it is certainly new. The scale at which we can do things today is new. So what is the delineation between traditional automation and an agentic AI?
Yeah, I guess I'm kind of a technology purist when I think about definitions. The IT industry is hard with definitions. Many people use the same words to mean different things.
Right.
And people say AI to me, I really think of this world of, LLMs is the classic thing. But again, I'll call it even at a more base level, like neural network design systems. One of the reasons
Mm.
people are so excited about NVIDIA is their GPU is really good at neural networks. It's a form of programming that is uh, vector math, which is why GPUs are so good at it and not traditional, I guess normal x86 CPUs are not as prevalently used for AI. So I really think about these neural network based, LLM type systems. They're real AI, and it's very different than traditional forms of automation, which are, more functional programming, if then else, loops, more classic programming design, I guess. And you mentioned something earlier, Eric. I'll tell you that resonates with me too about the difference between these two. Like in a world of AI agents, things like compliance and security and data quality, these things don't go away. But how you're going to implement these things in a neural network LLM type system where the LLM is kind of like it's almost like you can talk to it and it's thinking, but you can't always see why it's making the decisions it's made. Whereas in a
Right.
traditional form program, you could go through the code and you could see, well, here's exactly why it branched here, and this is the data it had, and it went over here. And it's very easy to figure out why it made the decision it made. But in an AI world, it's harder to tell with an LLM. Like why is it decided to recommend something to you. Like it's not as easy to figure out why the LM, but this auditing and compliance and security of the LMs is still going to be incredibly important in an enterprise. And that's also a reason I think this concept of a many agents in an enterprise, it does beget some system like a streaming system, like a Kafka system at the core. Because in our world, we've built a bunch of AI plugins. Like we've done all these connectors for enterprise apps. We've also done them for OpenAI and AWS Bedrock. And by the way, you can host your own LLM model because we believe some of these models are going to run inside the enterprise and
Mm,
not necessarily in an external third-party cloud service. You're still going to want tracking and authorization and auditability of all these things. And just think about every call that goes to an AI service showing up in a topic, in a Kafka
right.
topic, where you have the whole history of exactly what's happened. So you can look back and see at what point, which agent actually made which decision where, that you can actually log all these requests somewhere and have security and authorization around them. These constructs don't go away in an AI-driven world, from my perspective. You referenced it, and I want to say I 100% believe you're right. And it also begets this architectural framework where you have all these agents talking together. That is going to be a great point to do this compliance and authorization and auditability. So we're pretty excited about what the future holds for systems like Redpanda in this space. But we're also excited to see what happens because obviously, I don't think anybody, to your point, anybody knows exactly how it plays out.
Right. Well, and William, I'll throw this over to you. The aha moment I had with the large language models and comparing that with the database world is when I realized that when you're training the model, what you're really doing is you're populating all these parameters with weights and biases, and you can have billions of parameters in these models. In other words, when you store a string of text in a database and you call on that text, you want to get it back exactly as you put it in there the first time. That's the old-fashioned way of thinking about things. Now, with these neural networks, it's not like that. They're not storing the text. They may be storing, again, it's to Brian mentioned vectorizing, right? So vector databases, what you do is you convert text to a vector to a numeric value, which is really a point and a direction, an array basically in a certain direction. Cat all winds up in the same area, dog winds up in the same area in this vector landscape basically. And then when you prompt it, it converts first of all, it takes the prompt and it goes to this environment. It finds patterns that look similar, brings it back to you, and converts the numbers back to text. But the point is, that's a lossy process. So you are losing some fidelity in doing that, and you need to gain that fidelity then on the other end. And I thought to myself, we did a show just a couple of weeks ago where I thought this is really kind of a bizarre turn for the industry because we've spent all these decades now trying to improve performance, improve the deliverability, concurrent users, things of this nature, all built around core constructs like accuracy, like
Mhm.
atomicity, making sure it is the same as it was when it went in, when it came out. It's the data quality side. But now, if you throw this LLM at the end of the workflow, it's almost like introducing a noise filter at the end of the process. And now you have all this work that's being done to sort of ground these things with vector databases or graph RAG, as we'll talk about early next month on a webinar. So it's kind of bizarre, this thing that's happened. And now it's like, whoa, we've almost turned everything inside out to where we're now trying to harness and sort of slow down the LLM or shepherd what it does. But what do you think about all that, William?
Well, this is why the temperature setting for your use of an LLM is very important. Do you want it to be super creative and come up with wild results and be super randomized in terms of what it's going to give back to you, or do you want to have it more tight? But either way, when you're using an LLM, the idea of explainability is difficult. And we know that's coming. We know it's
Right.
coming where we're going to have to be able to explain our business decisions that are based on AI and based on LLMs or SLMs. We're going to need to know how to explain that in a certain way, maybe not down to great detail, but it's coming that we're going to need to know how to do that. But right now, we don't need to do that too much. So we're preparing for that. The thing about an AI agent is, and you asked earlier, what do we call an AI agent? Well, there are AI agent libraries, and the things that are put in there for now, for simplicity, I'm calling them AI agents, or kind of self-described. This doesn't mean that internally we aren't sort of building AI agents with AI and encapsulated functions and so on. Sure, that's happening, but these AI agents in libraries like Salesforce, Snowflake, etc., they've met a certain standard, and that's important
Mm,
that we understand the standard that those agents are built to. And
mm.
these are standards of security, as Brian was mentioning, and also governance, and also performance, and the temperature setting, and all sorts of things like that. So these are all important in the selection of the LLM, but there are alternatives that get you to Gen AI that don't involve an LLM and involve smaller language models that you curate from the large language model. And then you can also do that in conjunction with a RAG architecture where you tightly control the components that are selected from in order to do the Gen AI. So
Mm.
there's alternatives in there. Some are more explainable than others. So you have to look at each situation and determine how much explainability do we need? How much variability can we tolerate? Is this a creative type of application or not? And
Yeah.
go from there.
Yeah, that's a really good point, and I'm glad you brought up small language models. We got about 2 minutes left in this segment. I'll throw it over to Brian. I think that many corporations are going to look to build out their own small language models, and you can go to Hugging Face now and grab all kind of stuff that's open source and just populate it with your data, and that is a whole discipline and the universe unto itself, right? What do you think, Brian?
So one is there is a ton of open source options out there, for LLMs. Obviously, Meta and a whole bunch of other folks. DeepSeek got really popular in the news a couple of weeks ago.
Yeah.
There are a huge number of open source models today, and there's clearly going to be more coming. I do believe these small models are going to grow in stature. They're cheaper to run, obviously, and cost still matters. Okay, in a world of AI, not everything is funded by infinite VC money.
Yeah,
These things
that's
matter
right.
in a real world environment. And I absolutely agree. Small language models with RAG databases can be very powerful. And again, we've built a connector to Pinecone and to MongoDB and a whole bunch of the things that are classic, uses of RAG databases as they exist today. And you got to ask yourself, how does your LLM talk to your RAG database? Okay, I would assert Kafka is going to be a good architecture for such a thing again. Auditability between the two, tracking, etc. Performance, low latency, these things really matter. And I'm a huge fan that many enterprises they have so much data inside their organization
Right.
that they can't get it outside. It's too large, and it is proprietary in nature. It is their intellectual property, and if you're a drug company, you're not going to put your protein designs out on the internet for
Sure.
people to learn from. So we have this big thing about sovereign AI, about enabling people to run AI in their organization with models they host, and
Right.
in addition to
Right.
obviously support cloud AI models like OpenAI and all the other ones that are clearly going
That's
to exist and be successful.
that's crazy. Well, folks, podcast bonus segment is up next. We'll be right back. You're listening to DM Radio. All right, folks, time for the podcast bonus segment here on a fascinating show about streaming data with Brian Schwartz of Redpanda Data and William McKnight, the analyst consultant on our show today. And Brian, you made a good point at the break there a second ago that the old system, and I think about this all day long. I think it's just fascinating. The old systems are not going to go away, at least not anytime terribly soon. And the nice thing about these small language models is that they are less complex. I think that the unwieldiness of the LLMs stems from how complex they are. In fact, I had Dr. Usama Fayyad on my show at the beginning of last year as all this was just starting, and he made a really funny quote. He's like, "These large language models, they're too big. They're not supposed to work. We don't know why they work." It's like, okay, you run the Institute for Experiential AI at Northwestern University in Massachusetts, and you're like, "Oh, we don't even know how they work." But his point is that it is really opaque and dense, right? But as I think about it, the core systems like, because think about it, the accuracy issue is a really, really big one. 80% of the box, well, I ask people what percentage of your business can be wrong 20% of the time. And the answer is like almost nothing. Accounting, operations, fulfillment, none of that stuff can be wrong 20% of the time, let alone 10% of the time. So that's not going to go away. But to your point, this AI stuff is going to be additive more than it is to replace what's existing right now. What do you think?
I 100% agree with that. You made a bunch of comments about, classic, challenges on data management, atomic transactions, ACID compliance. All these things don't go away in an age of AI. You still need a supply chain that knows exactly how many widgets are on the shelf at a given
Right.
store or whatever. These things.
Right.
If you're running a manufacturing facility, okay, the parts better be there when the AI robot needs to go install it, right? Okay, these things don't go away. So I really believe the AI agents are an addition to all the classic enterprise apps that are out there. And the AI agents, again, you think about them, I hate to say like substitute for a person at some level because I don't think it's that simple. But
Right.
even in terms of an AI agent, it needs that context, it needs that data, it needs an operational system, a high transaction database if it's in finance about what's happening in the market right now. Okay, if you're an
Hmm.
AI agent in finance, you better know what's happening in the market now and not be trained on data from last week, last month, last year. That's not terribly interesting. And you still need all the analytics databases, the history that gets built up in an organization that's in Snowflake or Databricks or some big data warehouse. Even in an age of AI agents, they need that information as much as we do. So I don't think
Hmm.
any of those things go away. So I really think it's AI in conjunction with operational analytical systems exist. Uh,
Hmm.
to your earlier image generation analogy, AI agents today are not very stateful. They don't remember a lot of historical context of the last 5 questions you asked it. They need databases, they need data structures, they need all the things that do complex queries where you sort and merge and do joins.
Right.
It requires a lot of data and memory and network and all these things. These things don't go away and they don't naturally and easily just somehow end up in an LLM tomorrow. Think about the
Hmm.
most complex transaction you've seen against a data warehouse and the amount of CPU and processing and memory and network power that's needed for that.
Right. Right.
A
That's
large
just my
amount of crunching
point.
of the data. The LLM can slowly do it, but it's not necessarily a RAM heavy, disk heavy, SSD flash, high speed network. It doesn't have that same architecture inside of it the way a stateful app does.
Right.
These operate in conjunction with each other, from my perspective, and one doesn't replace the other. There's very few
Yeah.
situations in tech where the new thing 100% replaces the old thing. There are some in that,
Right. That's right. Well,
not as
it's
many as people think there are.
yeah, right. Well, you wind up with I always love this example of ancient cities where it's like, cities were built on top of other cities, but in this case, the stuff's still running, right? I mean, in the old days, they just like pour dirt over something and build on top of that. But you don't want to do that because you got all these, I mean, you got mainframes from 40 years ago that are still running at some large organizations and like, don't touch it. Operational guys are like, leave it alone. Do not touch that
For
thing.
25 years, I have a hard time imagining just next month they somehow all disappear. I don't know. It seems to be a pretty aggressive assertion.
That's right. And then maybe for closing remarks, I'm going to throw my curveball over at William McKnight. My fear of AI double agents. What happens if someone hacks into your registry and there's some sort of foundational principle that they obliterate or overwrite? Because you think about guardrails. Well, what are guardrails really going to be? They're going to be certain things like I think of containers and Kubernetes, right? Like there are companies that just manage and monitor all these containers, and sometimes they get stuck out there. They don't do what they're supposed to, and so you just kill that container and start it up again. Well, what happens if what's the worst thing that could happen if an agent watchtower, for example, is compromised, and then all of a sudden all these guys start doing bad stuff? Is that even possible? What do you think?
Well, if, as Brian says, agents are going to be talking to other agents, and I agree with that, then they can collaborate on meeting their goals. And if we do not give them discrete goals that are good for the company, and by the way, I agree that company goals aren't changing. They're still trying to drive profit, drive revenue, cross-sell, and that sort of thing. that's still there. Is AI needs to be able to that needs to be able to support those missions of the company. But if we do not put the guardrails on AI and say, yeah, do it, but don't forget about these other things,
Mhm.
then it will pursue those goals to all end, not
Right.
considering anything else, and then we can have chaos. So really the guidance of that, the human slash AI connection that guides this future that we're bringing on is going to be very important.
Yeah. And I'm going to throw one a splinker over at Brian because I'm a Pittsburgh Pirates fan these days. And White Sox fan still, but now that I live in Pittsburgh and my daughter is a huge Pittsburgh fan, we got this guy who throws splinkers. He's like the best pitcher in baseball right now. And here's my big question. I think that I came up with this concept a while ago that this age of AI is going to spell the end of the individual blowhard. And what I mean by that is some person in an organization who just stops things and prevents things from happening because it's the routes through that person, whether it's budgeting or whatever. And I think that's going to start to fall apart in part because of the power of agentic AI and AI in general, but in part because these sort of stovepipe bureaucracy constructs are very inefficient and have been very inefficient for a very long time. And you see around the world, different companies will come up with ways, and even countries and organizations and militaries to sort of deputize people to do more things so you don't have this top down bureaucracy, which I think is a real problem. But what do you think about that?
I can really see how you're, the breaking down of kind of the silos. And it really comes from, I agree with that. And it comes from the fact that AI, in some senses, if you think about it, kind of democratizes information uh,
Right.
in a way that, okay, I can't write, use the analogy of a CEO of a small company basically using AI agents to make a small business with very few people. They might not be able to write code, but if they have an AI agent that can write code, who's
Right.
along their head of engineering, okay, it kind of democratizes access to information. Or same thing on marketing, like then there'll be an AI marketing agent that's going to give you advice as to how to do marketing campaigns. And it allows kind of checks and balances in an organization and access to information because to use your, everyone's met kind of a blowhard. It's like they hoard information, they hoard expertise.
Right.
They don't.
Right.
And I think
That's such a
AI
good point.
agents are going to democratize that in a way that breaks down some of those silos. And that again is another positive thing. And we all, I agree with William's comment, we all need to harness and point AI at the right set of problems and control it and manage it. So it's used for all the good things out there. And, it's not used to hoard more information or other things like that that are obviously detrimental to organizations or just to society as a whole. So
Right.
human aspect of AI is ultra important. Uh,
Yes.
the responsibility for everybody in tech to basically buy into contributing to make sure it's used for all the right purposes and brings value to humanity.
I love it. That's what we want. Just like in Silicon Valley, right? Make the world a better place. That's what all the technology companies are doing.
And
But collectively, I think we can do that, but we do have to stay focused to your point. Well, folks, look these gentlemen up online. Brian Schwartz is with Red Panda Data. I love that name. And William McKnight of William McKnight Consulting. Send me an email if you want to be in the show. info@dmradio.biz. Email's still a thing. It's not going away. We'll talk to you next time, folks. You've been listening to DM Radio.